Well, hello, my friends. Welcome to episode number 456 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. I am very excited to bring in Peter Peumans from Imec today. Peter and I are talking about an exciting breakthrough in COVID-19 testing, spearheaded by Imec and miDiagnostics. We take a closer look at what sets this new kind of testing apart from other methods on the market today, the details of Imec's silicon chip technology that lies at the heart of this new testing method, and how this new kind of technology could revolutionize how we test for other infectious diseases in the future. But before we bring in Peter, you know it, you love it, it's time for a little news you may have missed. So, what if we could 3D print functional and structural materials into a single streamlined printing platform? Would that usher in a new era in wearable devices? A group of researchers at the University of Notre and Purdue University think so. So get this. This team of researchers from these two distinguished universities have created an innovative new hybrid 3D printing method that combines extrusion printing with multi-material aerosol jet printing that does in fact integrate both structural and functional materials into one printing platform. Oh, and with this new printing process, they have developed a completely printed piezoelectric wearable device. Yanliang Zhang, Associate Professor of Aerospace and Mechanical Engineering at the University of Notre Dame, explains the benefits of developing this new kind of 3D printing process like this. The biggest advantage of our new hybrid printing method is the ability to integrate a wide range of functional and structural materials in one platform. This streamlines the processes, reduces the time and energy needed to fabricate a device, while also ensuring the performance of printed devices. So, what does this new all-printed piezoelectric wearable device look like? Well, using this new kind of printing process, this team integrated tellurium nanowire piezoelectric materials with silver nanowire electrodes and silicone films into stretchable piezoelectric sensors. So when these devices were attached to a person's wrist, they were able to accurately detect hand gestures. And when they were attached to a person's neck, they were able to detect that person's heartbeat. And as you can undoubtedly guess, neither device needed an external power source. Two keys to the success of these devices are those nanostructured materials with piezoelectric properties, and the silver nanowire electrodes, which were important to keep the wearable device attached to the body, especially when it was in motion. So, have we come upon a new frontier in 3D printing? Maybe so. If you want even more information about this study, I've included a couple links below the player on this week's Fish Fryin' page on eejournal.com, including the associated research paper called Hybrid Printing of Wearable Piezoelectric Sensors. All right, it's time to talk about a new frontier of COVID-19 testing. The Breathalyzer. Please welcome Peter Peumans from Imec. Hi, Peter. Thank you so much for joining me.
Hello, how are you?
I'm great. Thank you for asking. So today we're taking a closer look at a new agreement between miDiagnostics and Imec to commercialize a new fast and reliable COVID-19 diagnosis. So before we dig into the details, can you talk about this test a bit? How is it different from current COVID-19 testing methods?
Sure, yeah. As most of us know, current COVID testing is based typically on swabbing. So you take what's called a nasopharyngeal swab, enter the nasal cavity where you pick up a sample to then do a molecular analysis of that sample. An alternative you have is to take a saliva sample. Now, what these methods have in common is that they're relatively invasive because you've got to go in the nose, you've got to take saliva. And then maybe even more importantly is that measurement is not really a measurement of your contagiousness. It's a measurement of how viral application is happening inside you. What we are working on, or what we've worked on and have now licensed to miDiagnostics, is a technique that actually measures how much virus you're exhaling, which in the context of a pandemic, we think is a more important measurement to do.
Absolutely. Now, Imec's silicon chip technology lies at the heart of this new test, right? Can you talk about that aspect of the design a bit?
Yeah, sure. Indeed, the chip is a key aspect. It's actually been known for a while in respiratory infectious diseases such as influenza, probably also in tuberculosis, and now also in COVID, that aerosols are actually one of the main ways in which the virus transmits. Now, not a whole lot of people have looked at aerosols because it's really a hard sample to collect. There just wasn't equipment available to do any kind of large-scale clinical studies. And that's what we've changed through a new type of chip. The chip's unusual because it's a chip you can breathe through. So it's a chip with many perforations that allow you to breathe through it. And the perforations are organized in such a way that when air enters and when you exhale, air enters the perforations. And then somewhere in the middle of the chip, the air will take a very quick turn as forced by the geometry of the chip, and then will exit through another hole. And so it's in that quick turn that the small particles, or also called aerosols, will be collected by a process called impaction. And so making that process efficient, and so in the sense that even for the small particles you can exhale, still want, let's say, a 90% collection efficiency. And at the same time, we want the chip to be easy to breathe through. And at the same time, we want the chip to be compact. That was only possible using silicon micromachining technologies. So that's where chip technology really made a difference. It allowed us to collect a sample that was just almost impossible to collect before in a way that is compatible with the consumer experience.
That's great. Now, tell me about the development of this breathalyzer test. It seems like quite an impressive accomplishment in a relatively short amount of time.
That's true. So, of course, we were driven by the need for a new way to perform testing in a pandemic. Relatively early on in a pandemic, I would say it's spring of 2020, March, April, May, it became relatively clear that aerosols played an important role. And so over the summer of 2020, we developed a concept that we thought could actually collect these aerosols efficiently. And we did the first designs at the end of the summer and then started spinning silicon. And then in December of 2020, we started doing first clinical studies. So we actually went from concept to silicon and then to a device we could take into a clinical environment relatively quickly, I would say in the space of maybe 4 months or so. And that's actually, at least for us, and I think for many parties, unseen. And of course, had to do with the sense of urgency that was there because of the COVID pandemic. We had teams extremely motivated. The teams worked through nights and through weekends, as that's what you get when there's an important cause ahead of you. And I do remember the first days where we were looking at, okay, we're expecting a clinical result. We're all sitting in our chairs, eagerly awaiting that result. Those were really anxious, but at the same time, fun times.
Absolutely. I can imagine. Now, Peter, this new test will debut at the Brussels airport in November, right? But there are bigger goals on the horizon for this type of technology.
Yes, indeed. So I think the larger part of the story is that this is really a new sample type. So exhaled aerosols, undiluted, have not been collected using a portable device. So suddenly now we've created something that gives you access to this unique sample. This is a sample that originates inside your respiratory tract and lungs. It's a very clean sample. It's also a highly concentrated sample. And today we've shown that for COVID, it gives you some unique value in the sense that it's a really non-invasive test, easy to perform. It measures through infectiousness as opposed to having an infection. And in some cases, we can even see that this breath-based approach detects an infection earlier than the other approaches based on nasopharyngeal swabs or saliva. So it has a lot of value for COVID. But indeed, the bigger part of the story is that there's other diseases where this kind of sample may be really interesting and informative. Just a couple of weeks ago, in fact, there was an important meeting on tuberculosis. And this field has just recently come to the conclusion that, hey, aerosols actually play a really important role and they could actually be driving transmission as opposed to coughing, which was the older idea. And so this field has come to the conclusion that aerosols play an important role too. And then beyond TB and COVID, any respiratory infection could potentially use a sample. And we think there's also use cases beyond infectious diseases. Again, because it's a relatively intimate sample, it's a liquid inside your lungs. So we're also setting up studies to go and discover what else you might pick up in this new sample type.
That's super cool. Now, Peter, I was also very interested in this announcement because of the interaction between research, entrepreneurship, to provide a real economic and social value. Can you address that aspect a bit? And why is this type of collaboration so important for Imec?
Well, we are a nonprofit organization, and actually everything we do is actually driven by societal impact. The position we're in is that we are a leading organization in terms of providing state-of-the-art technologies to the semiconductor industry. We then try to leverage that position to build tools for healthcare that really change the game. It could be a new way to do DNA sequencing that makes it a lot cheaper, which has impact, for example, on how you might actually diagnose and treat a cancer patient. It has impact on point-of-care diagnostics, where we could actually enable more tests at the point of care. Or in the case of COVID, it has impact because we can develop this new type of test, which is less invasive and more precise, and hence would help us manage the pandemic. All of our folks are always driven by that end game, what can we enable? And that motivates us. So absolutely, it's bringing all of that together. It's how can we make a difference? What's in our technology toolkit, and whom do we work with to enable it? So an important aspect is that it's not just about showing that it works and then publishing a nice paper, but it's also then looking for the partners that will actually take it all the way to a product that will be used by patients or customers.
Yes, absolutely. I love that, Peter. All right. Well, Peter, it's time for your off-the-cuff question. Now, since you haven't been on my show before, I ask the same question to most of my guests. So here we go. If you could have one meal right now, Peter, it doesn't matter if it's on the other side of the planet, what would you have?
Well, there's one meal that maybe I'll choose today, and it's something unique because they only make it in Belgium, I think. So there's a vegetable in Belgium. We call it wheatloaf. I think you call it endives in English. And it's not grown in a whole lot of locations, but we grow a lot of it. It's kind of a bitter thing, so a lot of people don't tend to like it, but we make it in a unique way. And it's made we first wrap the endives, so they're essentially shoots of a plant that's never seen sunlight, so white shoots. You then wrap it in ham, and then you pour a sauce over it, a cheese-based sauce, and then put it in the oven. And that would be my choice today because it's extremely tasty, and it's something that not a whole lot of people will actually have tasted. So if they ever get a chance to taste Belgian endives à la Flamande, as they say, in the Flemish way, I would encourage you to do so.
That sounds absolutely delicious, Peter. I've never heard of that, and it's on my bucket list for food right now. That sounds amazing. Awesome. Well, thank you so much for joining me, Peter. I really enjoyed this interview.
Great, me too.
And before we go, don't forget to check out my new maker-themed monthly fish fry podcast series called Makers Today. In our 5th episode of this series, I chat with Guido Bonelli from Dr. Duino. Guido and I chat about how art and electronic design intertwine in his life, how his Dr. Duino brand got started with a little help from Kickstarter, what his creation, the Goonie Box, is all about, and how the COVID-19 pandemic inspired him to create the social distancing Arduino project. And you can check out this episode by clicking the link below the player on this week's Fish Fryin' page, or you can also go to the Fish Fry archive on eejournal.com. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into Twitter, you can monitor our tweets at EEJournalTFM. And don't forget, if you want to follow my personal Twitter account, check out Amelia D. 1978. And hey, if LinkedIn is more your thing, sure, I dig it. You can follow me or us on LinkedIn as well. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by yours truly. And you can subscribe to our EE Journal YouTube channel as well. Also, by clicking the links below the player on this week's Fish Fryin' page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. It really does help. Also, if you'd like any further information about the stories covered in today's show, just head on over to eejournal.com and look for this week's Fish Fryin' page. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on eejournal. For the week of November 5th, 2021, I'm Amelia Dalton, and you've been fried.